Hey guys, in this video, I'm not gonna share easy and normal questions. Instead, I'll be telling real and tricky interview question and answers for the experienced people. And trust me, 99% questions from multi-threading will come from this video. Please like, subscribe, and watch this video till the end. And going forward, I'll be making the videos for other topics as well. So now let's get started. Is a thread lighter than a process and can exist without it? Actually, a process is an instance of a program that is being executed. When a program runs, the operating system creates a process to manage its execution. For example, when we open Microsoft Word, it becomes a process in the operating system. Whereas a thread is the smallest unit of execution within a process. A process can have multiple threads which share the same resources but can run independently. A web browser like Google Chrome might use multiple threads for different tabs, with each tab running as a separate thread. So the answer is yes, thread is lighter than process and cannot exist without a process because it lives inside the process. For example, process is like a house and thread is like a room. Multiple users hit the same REST API at the same time. Are they served by one thread or multiple? Actually, they are served by multiple threads. When many users hit the same REST API at the same time, the server assigns a separate thread for each request. So request can run in parallel, not one by one. Okay. What are the different ways to create thread? In older Java, there were mainly two ways to create a thread. First is extending the thread class, second is implementing the runnable interface. From Java 5 onwards, thread can also be created using the executor service framework along with callable. And from Java 8 onwards, thread can be created using lambda expressions which make the code more concise and readable. Can you tell me the difference between extending thread and implementing runnable and when to use each? So in extending thread, when we extend thread, our class becomes a thread. We put our code in the run method and start it using start method. But the limitation is that our class cannot extend any other class because Java allows only one class to be extended. When to use? Simple demos or learning purposes, very small programs where inheritance is not needed. In implementing runnable, when we implement runnable, our class represents a task, not the thread itself. We put a logic in the run method and pass it to a thread object. Here our class can still extend another class. When to use? In real world applications where our class already extends another class. Okay. Can a class extend thread and implement runnable together? Yes, a class can extend thread and also implement runnable at the same time, but it makes no real sense. Why? Actually, thread already implements runnable, so if your class extends thread, it automatically becomes a runnable. Implementing runnable again adds nothing. Why is runnable preferred in real world applications? Runnable is preferred in real world applications because it gives better design and flexibility. When we use runnable, our class only defines what work to do, not how to run the thread. This keeps things clean and reusable. Our class can still extend another class, which is very common in real projects. What happens internally when we call run method instead of a start method? When we call run directly, no new thread is created. What actually happens is the run methods runs like a normal method call. It runs on the same thread that called it, usually the main thread. Java does not create a separate thread or do any scheduling. When we call a start method, Java basically creates a new thread. That new threads then calls run method internally. Can one runnable instance be used by multiple threads? Yes, one runnable instance can be used by multiple threads, meaning we can create one object that has the run method code and then give that same object to many thread objects. What happens if start method is called twice on the same thread? If we call start methods twice on the same thread, Java throws a runtime error. What exactly happens is the first start works and creates a new thread. The second start causes an illegal thread state exceptions. Why this happens? A thread in Java can be started only once. After it is started or finished, it cannot be restarted. Hey guys, before moving to the next questions, I would like to share one important thing with you. Actually, we have a complete interview preparation material structured step by step by myself, expert and MNC's interviewers. And the best part is that now no one need to go anywhere else to prepare interviews. there is a 99% chance that interviewers will ask questions from this material. You can check the reviews as well. So basically it contain a lot of material categorized by experience level, means each experience level has different material with all possible interview question and answers. For Java, Spring Framework, Maven, Git, Spring Boot, Spring Security, Spring Data JPA, Kafka, microservices, Java coding questions, Stream API coding questions, and many more. I have provided the link to get this in the below description. And if someone need this material plus two real enterprise client projects for reference, plus one-on-one lifetime doubt sessions and referrals to the big MNCs, then they should check the interview preparation kit. I will provide the link for this as well in the description below. So now moving to our questions. Can you please explain the life cycle of a thread? A thread in Java goes through different states from start to end. This is called the thread life cycle. First is new. The thread is created but not started yet. Example, when we create thread T is equal to new thread. Second is runnable. When we call the start method, the threads becomes runnable. It is ready to run and waiting for CPU time. Third is running. The thread is actually executing its code, means run method. This state is managed by the CPU scheduler. Okay. Fourth is blocked or waiting. The thread is temporarily not running. This happens when it is waiting for a lock. It calls sleep method or wait method. It is waiting for another threads to finish. Okay. Fifth is terminated. The thread finishes its work or stops due to an error. It cannot be restarted. Can a thread re-enter runnable after terminated? No, a thread cannot re-enter runnable after it is terminated. Once a thread finishes its run method or ends due to an error, it basically goes into the terminated state. At this point, the thread's lifecycle is completely over. Java does not allow restarting a dead thread. If we try to call start method again, Java throws an exception. If two threads are trying to update a counter variable in a get counter method, so what will happen and how could we solve that? If two threads try to update the same counter at the same time, a race condition can happen. What will happen? Both threads may read the same old value of the counter, increase it and write it back. Because this happens at the same time, one update can override the other, so the counter value becomes wrong or inconsistent. And how can we solve this? We could use synchronized, so only one thread can update the counter at a time, or we could use atomic integer which safely updates a value without locking, or we could use locks. How can we use synchronize keyword? First is synchronize method. We can add synchronize keyword before the method name and lock the entire method. Second is synchronize block. We can create a synchronize block by curly braces and lock will be there in that particular block. Third is static synchronize. Here we lock the class, not the object. We add synchronize keyword after static keyword and before method name. Is synchronize applied to code or to the objects? Synchronize is applied to the objects, not directly to code. When we mark a method or a block as a synchronize, the code gets a lock on an object before it runs. Only one thread can hold that object's lock at a time. For an instance synchronize method, the lock is on the current object. For a static synchronize method, the lock is on the class object. What happens if an exception occur inside a synchronized block? If an exception occurs inside a synchronized block, the lock is automatically released. Let's understand step by step. A thread enters the synchronized block and gets a lock. An exception occurs inside the block. The thread exits the block because of the exception. Java releases the lock automatically. Can synchronization guarantee thread ordering? No, synchronization does not guarantee thread ordering. What synchronization does, it makes sure only one thread at a time enters the critical section. So basically, a critical section is a part of code that accesses shared data and must not be executed by more than one thread at the same time, like counter. It protects shared data from corruption. What it does not do, it does not decide which thread goes first. It does not control the execution order of threads. Thread scheduling is decided by CPU and JVM, not by synchronized keyword. Okay. What are the limitations of synchronization? Synchronize help keeps data safe, but it also has some limitations. First limitation is performance issue. Only one thread can enter at a time, so other threads wait. This can slow down the application when many threads are used. Second is no fairness guarantee. Synchronize does not guarantee which waiting thread will get the lock first. Some threads may wait longer. Third is risk of deadlock. If locks are taken in the wrong order, threads can wait forever for each other. Fourth is blocking nature. Waiting threads are blocked and cannot do any work and cannot do any other work. Fifth is hard to control. We cannot try to get a lock, set timeouts, or interrupt a thread waiting for a synchronized lock. Because of these limitations of synchronized, reentrant lock was introduced in Java 5. What is reentrant lock and why do we need it? A reentrant lock is more powerful locking mechanism in Java that controls access to shared code or data. What reentrant means is the same thread can lock the same lock again and again without getting stuck. It can also unlock the same number of times. Why we need it? Reentrant lock was introduced to solve problems of synchronized. It basically allows more control over locking and unlocking, ability to try to get a lock without waiting forever by try lock method, setting fairness so threads get the lock in order, waiting with time limits, using multiple condition variables. Okay, how reentrant lock works: we can use the lock method to lock the critical section and use unlock method to release the lock once our work is done. We could also use try lock method. It does not block forever. If the lock is already held by another thread, it immediately returns false, so thread can do something else instead of waiting. How does try-lock method prevents deadlocks? Try-lock methods helps prevent deadlocks by not forcing a thread to wait forever for a lock. What normally causes deadlock? Two threads hold different locks and wait for each other's lock. Both wait forever. How try-locks helps here? A thread tries to get the lock. If the lock is not available, it fails immediately or after a short time. The thread can then release other locks, retry later, or do something else. Because the threads does not block forever, circular waiting is avoided here. What happens if we forget to unlock? If we forget to call unlock, the lock is never released. What happens then? Other threads will wait forever to get the lock. The program may appear stuck or frozen. This can lead to deadlock or starvation. The only thread that can release the lock has already finished or moved on. When should you prefer reentrant lock over synchronized? We should prefer reentrant lock over synchronized when we need more control over locking. Use reentrant lock when we don't want threads to wait forever. We need fairness, so threads gets a lock in order. When we want to lock and unlock at the different places in the code. When we want better handling in complex multi-threading scenarios. And use synchronized when the logic is simple, when we want automatic lock handling, or readability and safety matters more than flexibility. What is volatile keyword? Volatile is used to make sure that when one thread changes a variable, all other threads see the latest value immediately. It avoids the problem where threads use old or cached values. Each thread keep its own local copy of variables in CPU cache or registers, but volatile read values directly from the main memory. Let's take an example. Imagine we have a music player app with a play thread that keeps playing songs in a loop. There is also a stop button handled by the main thread. Both threads share a variable called stop playing. Play thread keeps checking stop playing. When the user clicks stop, the main thread sets stop playing to true. If stop playing is not volatile, play thread may keep using an old cached value and continue playing forever. But if stop playing is volatile, play thread immediately sees the updated value and stops playing. Why doesn't volatile guarantee atomicity? Atomicity means an operations happen in one single step. Many operations like count plus plus are actually multiple steps, means it read values, increases and write back. Volatile only guarantees visibility, not that these steps happen together. So two threads can still read the same value and update it at the same time, causing wrong results. Okay. Can volatile fix race conditions? No, volatile cannot fix race conditions. What volatile does, it basically makes sure all the threads see the latest value. That's called visibility. What a race condition needs, atomicity, means only one thread updates at a time. What is atomic class and how do atomic classes work internally? Atomic classes like atomic integer, atomic long are special Java classes that let multiple threads update shared values safely without using locks. They are used when many threads need to change a value at the same time. like counters. How atomic classes work internally? Atomic classes use a technique called CAS, compare and swap. Simple idea of CS is it read the current value, check if it is still the same as expected. If yes, update it. If no, try again. If another thread changes the value in between, the update fails and CS retries. Why are atomics faster than synchronized? Atomic classes are faster than synchronized because they avoid blocking threads. With synchronized, threads wait and block. If the lock is taken, blocking and waking thread is slow and costly. With atomic classes, thread do not block. They use CS to retry instead of waiting. If an update fails, the thread just tries again. So less waiting, no lock management, and fewer context switching. What is Executor framework and why do we need it? The Executor framework is a Java feature that manages thread for us. Instead of creating and starting threads manually, we submit tasks and Java decides which thread runs them and when. Why we need it? Creating threads again and again is slow and hard to manage. We also have to handle how many threads to create, when to reuse them, and when to stop them. So basically, the Executor framework reuse threads, controls how many threads run at once, makes code cleaner and safer, improves performance and scalability. Can you please explain the concept of thread pool? A thread pool is a group of ready-made threads that are reused to do multiple tasks. Instead of creating a new thread every time a task comes, the thread pool gives the task to an existing idle thread. When the task is done, the thread goes back to the pool and waits for the next task. Let's take an example of restaurant kitchen. The threads are basically the chefs. The thread pool is a set of chefs already hired. Orders are the task. So when a customer places an order, the restaurant does not hire a new chef every time. An available chef takes the order and cooks it. After finishing, the chef becomes free and takes the next order. If all the chefs are busy, now new orders wait in a queue until a chef is free. Who manages the thread lifecycle in executors? The executor framework manages the entire thread lifecycle. It creates threads, assigns tasks to them, reuse them, and shuts them down when needed. We don't manage threads manually here. Can executors reuse the same thread for different tasks? Yes, executors reuse the same threads to run many different tasks. After a task finishes, the thread goes back to the pool and waits for the next task. What happens if the executor queue is full? If both the thread pool is busy and the task queue is full, the executor rejects new task. This usually throws a rejected execution exception or follows a rejection policy like running the task in the caller thread or discarding it. Can you tell me the difference between submit and execute method? Execute method is used when we just want to run a task and don't care about any result. It takes a runnable and returns nothing. If something goes wrong inside the task, it is thrown directly on the worker thread and usually ends up in the logs via threads exception handler. Whereas submit method is used when we want more control over the task. It returns a future which lets us check whether the task is finished, cancel it, or get a result. If the task throws an exception, it doesn't crash the thread immediately. Instead, the exception is stored and is thrown when we call future.get. Because of this, submit method is safer and more flexible and is generally preferred in real applications. Can you tell me the difference between runnable and callable in executors? In Java, when we use threads or the executor frameworks, we don't directly tell a thread how to run. Instead, we tell it what work to do. That work is represented using runnable or callable. So threads and executors manage threads. Runnable and callable represents the task that a thread will execute. Both are used to define the code that's run inside a thread, especially when using executor service and thread pools. Talking about runnable, it does not return a result. It cannot throw a checked exception. It is used for tasks that just perform work. Whereas in callable, it returns a result. It can throw checked exceptions. It is used when we need an outcome from the task. Explain the type of thread executors. There are multiple types of executor. First is fixed thread executor. Here we define how many threads should work. For example, if we create an executor like this, executor es is equal to executors.new fixed thread pool. Here we have fixed that 4 threads will be in use. It means at most 4 threads can run in parallel. If more than 4 tasks are submitted, the extra task will wait in a queue until a thread becomes free. Basically, it's a pool with a fixed number of threads. Second is single thread executor. Here we define that only one thread should work. For example, if we create executor like executor service es is equal to executors dot new single thread executor, here only one thread will be created. It means only one task can run at a time. All other tasks will wait in a queue and executes one by one. Basically, it is a pool with exactly one thread and execution is sequential. Third is cached thread executor. Here we do not define any fixed number of threads. For example, if we create executor like es is equal to executors dot new cached thread pool, in this executor, new threads are created when needed. Idle threads are reused. Threads that stay idle for some time are destroyed. It means that numbers of threads can increase or decrease automatically based on the load because it is dynamic thread pool. If too many tasks come, it may create too many threads, which can cause performance or memory issues as well. Fourth is scheduled thread executor. This executor is used when we want to run tasks after a delay or repeatedly. For example, if we create executor like schedule executor service es is equal to executors.new schedule thread pool. Here two threads are available for scheduled tasks. We can run a task after some delay, run a task at fixed time intervals. Basically, it is used for time based tasks like background jobs or periodic checks. Fifth is fork join pool executor. This executor is used for parallel processing. For example, if we create executor like fork join pool, pool is equal to new fork join pool. In this executor, a big task is divided into the smaller tasks. These tasks run in parallel. Idle threads can still work from busy threads. Basically, it is useful for CPU intensive tasks and divide and conquer problems. What is completable future and how does it work? Completable feature is used to run tasks asynchronously and chain multiple steps without blocking. And how it works? We start a task. While it runs, our main thread is free. When the task finishes, we can say, then do this, then do that. Simple words: order food, food gets prepared, then delivered, then notify customer. Each steps run automatically after the previous one finishes. Okay. How do you handle exceptions in completable feature? Completable feature has built-in exception handling methods. Exceptionally method give a fallback value. Handle method handle success or failure together. When complete method just log or observe errors. Simple idea is if something fails, we decide what to do next instead of crashing the program. Can completable feature cause thread starvation? Yes, if used incorrectly. By default, completable feature uses the fork join pool common pool. If tasks are blocking, too many long tasks run, then thread gets stuck, new task wait forever. This is called starvation. Solution is we could use a custom executor for blocking tasks. Why is completable feature better than future? Problems with the future is we must call get method, no chaining, poor exception handling, whereas in completable features there is non-blocking, task chaining, better exception handling, and combine multiple tasks easily. What are common methods in completable feature? Completable feature provides many methods to run and manage asynchronous tasks. We can create async tasks using methods like supply async when we need a result and run async when no result is needed. After a task complete, we can chain next actions using then apply to transform the result, then accept to use the result, or then run to run another task. To work with multiple async task methods like then combine, then compose, all of, and any of are used. Completable feature also offers strong exception handling through exceptionally handle and when complete method. If needed, we can block and get the result using get or join method. It also provides control methods like complete method, cancel, or is done to manually manage or check the task state. What is ForkJoinPool and its real example? ForkJoinPool is a special thread pool designed for divide and conquer a task. How it works? Basically, a big task is split into the smaller task, that is fork. Results are combined, that is join. Idle threads can still work from busy threads. Real examples are searching a big array, parallel sorting, processing large data in chunk.